step back and think about the big picture now. When again it comes to this new complementary way of assessing if we have developmentally meaningful input differences. And again, we were using developmental computational modeling to complement the existing standard techniques for assessing if we have these developmentally meaningful input differences. So the standard way is a correlational story. Our new complementary is a causal story, but you then need to see if the predicted differences are actually there. Right? So in this case, we demonstrated this technique for syntactic island knowledge and in fact predicted no meaningful input differences across socioeconomic status, right? So even though there might be, or in fact are, input differences, they're not meaningful developmentally, right? They don't matter. They don't impede learning, or they are not predicted to impede learning of syntactic island knowledge. So this means that we predict no input-based interventions would actually be impactful. If we actually find that there are differences in the acquisition of these syntactic islands across socioeconomic status, across SES, it's not because of the input, right? So input-based interventions are not going to help, right? Like that is what we learn from this approach. And something useful is that, as I mentioned a little while ago, this technique can provide a causal explanation for how input differences could affect learning outcomes, right? We know exactly why the input has the impact that it does, right? Because we have a concrete theory of the learning that takes place on the basis of that input to acquire the appropriate knowledge. And here for syntactic islands, the building blocks needed for this knowledge, in this case the WH dependencies, the syntactic trigrams, these don't seem to differ enough to matter across SES, again, to impact, or at least are not predicted to impact the development of syntactic island knowledge. So something else that's useful is that this technique can make predictions about differences we expect in both child outcomes, right? In this case, we don't really expect differences in outcomes for children, but also eventual adult knowledge, where in fact we do predict that there's going to be a difference, in this case with the what is a VAT trace violation for a high SES speaker, but we predict it shouldn't be for a low SES speaker because it provides a crucial building block for low SES children to learn these syntactic islands. This is an example. Again, what do you think that happens is our example of this type of WH dependency knowledge. And something that's important, of course, again, I want to reiterate this, why this is a complementary method to the standard way, is any predicted outcome differences still need to be measured. But we know what to look for. We can design targeted experiments to assess these predicted outcome differences on the basis of the model predictions. Something that's a bonus, really, I think, which is really worth considering, is that modeling like this developmental computational modeling, is often faster and cheaper to do than behavioral work with children, which is painstaking and beautiful and really hard to do, right? And very time-consuming to do well, right? So modeling is often faster and cheaper to do, so it can be a very useful first pass input quality assessments. Definitely something that we should add to our toolkits if we care about assessing input quality. An extra bonus, I think, in these particular pandemic times is it's possible to do it, right? Because you're working with data that's already been collected, in this case, input samples, right? So you can do this even if it's difficult to interact with live children, right? So that's an extra bonus, I think, for this kind of technique for assessing input quality. So to kind of wrap up, I think that given all of this, we got to use developmental computational modeling when we want to identify and understand developmentally meaningful input variation, and I've showed an example of how to do that here. So thank you very much, and thank you especially to my collaborator on this, Alandi Bates, and thanks.